How are you, my dear students? I'm Mr. Mohammed Albadry, teaching grade 11 bilingual. Welcome to our private school, Tabarak, from our educational platform. We have to thank our chairman, Mr. Yunus Rahbi, who gives us this wonderful opportunity to contact with our dear students. And today we are going to study trigonometric identities in the unit of trigonometry, and this is the first lesson in trigonometry. It's very important to know the basics of the trigonometric identities. Firstly, tan theta equals sine theta over cosine theta, and the second, sine square theta plus cosine square theta equals to 1. And from this identity we have two identities. If we move sine square theta to the other side, it will be 1 minus sine square theta equals cosine square theta. And if we move cosine square theta to the right side, we will have sine square theta equals 1 minus cosine square theta. And the third one, sine 90 minus theta equals cosine theta, and cosine 90 minus theta equals sine theta. Now we are going to take an example. How could we make replacement? How could we substitute the values? If x equals a sine theta, simplify x over a square minus x square under square root. So firstly we have to replace x with a sine theta and x square with a sine theta, but we will put it inside square root and under square by substituting x equal a sine theta into the relation x over square root of a square minus x squared. So x becomes a sine theta and x squared here inside brackets a sine theta all squared. And if we expand it, we will have a square over sine squared. And again here we have a and a, we are going to take it as a common factor. If we take a square, a common factor from the first one, by divided we will have 1. And if we divide it here by a square, we will have sine square theta. And 1 minus sine square equals cosine square. So a sine theta over a square cosine square theta, we will take it from inside square root to outside square root. So the square root of a square sine a square cosine square will be a plus or minus a cosine theta. And by simplifying a by a, we will have plus or minus, and sine over cosine equals tan theta. And now the simplification of x over square root of a square minus x squared will be positive or negative tan theta. For the next example, here, if exercise 16c number 1g page 275, if s equals sine theta and c equals cosine theta, simplify the relation of s times square root of 1 minus s square over c times square root of 1 minus c square. It's easy now. We are going to replace each letter by the relation. So times square root of 1 minus s square over c times square root of 1 minus c square. It's easy now. We are going to replace each letter by the relation. So s times square root of 1 minus s square becomes sine theta times 1 minus sine square theta, and c times square root of 1 minus c square becomes cosine theta times 1 minus cosine square theta. Sine over cosine as it is, but we have 1 minus sine square is cosine square, and 1 minus cosine square is sine square here. And after that, here the square root of cosine square is cosine, and square root of sine square is sine. And now when we simplify it, becomes sine by sine, cosine by cosine, we will have it 1. So the simplification of the fraction of s times square root of 1 minus s square over c times square root of 1 minus c square equals to 1 minus c square equals to 1. So here for the second example. For the third example, exercise 16c, number 12c, page 277. Eliminate theta from these equations when x equals 4 minus cosine theta and y equals 2 plus sine theta. How could we eliminate them? We have to simplify it and find. For the first relation here, we have x equal 4 minus cosine theta. So move cosine to the other side and x to the right side. So cosine theta equals 4 minus x. The same, we have y equals 2 plus sine theta. Move y to the other side. We will have sine theta equals y minus 2. Using the identity of sine square theta plus cosine square theta equals to 1. So we will have sine squared will be y minus 2 squared, and cosine square equals to, yes, 4 minus x squared equals to 1. Here we eliminate theta, but if we want to expand the brackets, y minus 2 squared will be y squared minus 4y plus 4, and 4 minus x squared becomes 16 plus x squared minus 8x. All of it equals to 1, and we are going to collect the like terms. It will be y squared plus x squared minus 4x squared minus 4x minus 8x plus 19 equals to 0. And now for the next example, here how could we prove that sine power 4 theta minus cosine power 4 theta equals to sine square minus cosine square theta? We have the left hand side here. How could we prove the identity? We have here even power, and between them is minus, so here we have difference of two squares. So factorizing using the difference of two squares for the left side, it will be sine square theta minus cosine square theta, sine square theta plus cosine square theta. One bracket is negative and the other bracket is positive. So we have the relation here, sine square plus cosine square equals to 1. So sine square theta minus cosine square theta equals the right side, and here we prove it. Here we have a difference of two squares because we have even power, and between them is the sign between them is negative. Yes, so we are going to factorize it as a difference of two squares and simplify it. We will have the right side. So sine power 4 theta minus cosine power 4 theta equals sine square theta minus cosine square theta. Sine power 4 theta equals sine square theta minus cosine square theta. Now for number 8, exercise 16c, number 13a, page 277, prove that tan theta plus 1 over tan theta equals 1 over sin theta cosine theta. We know that tan theta equals what? In the left side, tan theta equals sin theta over cosine theta. So we are going to replace tan theta in both of them. So tan theta equals sin theta over cosine theta, and 1 sin theta over cosine theta, and 1 over sin theta over cosine theta. 1 over sin theta over cosine theta will be cosine theta over sin theta. Now, like algebraic fractions, how could we add it? We have to make the numerators the same terms. So the first one we multiplied by sin theta over sin theta, and the second we multiplied by cosine theta over cosine theta. So now here it will be sin square theta over cosine theta sin theta, and the second cosine square theta over sin theta cosine theta. And sin square theta plus cosine square theta is equals to 1. Using this identity, so it will be 1 identity, so it will be 1 over sin theta cosine theta or cosine theta sin theta. This is the right hand side. So tan theta plus 1 over tan theta equals 1 over sin theta theta. And for example 6, exercise 16c, number 13b, page 277, we have to prove 1 over sine theta plus tan theta over cosine theta equals to 1 over sine theta cosine square theta. The same idea 1 over sine theta plus 1 over tan theta over cosine theta. We know that the identity tan theta equals sine theta over cosine theta. So 1 over sine theta plus sine theta over cosine theta over cosine theta over here means cosine times cosine equal cosine squared. So 1 over sine theta times cosine square over cosine square plus sine theta over cosine square theta times sine theta over sine theta. Why we make it like this? Because we have to add these algebraic fractions. So we'll 1 over cosine square theta over sine theta cosine square plus sine square theta over cosine square theta sine square theta. Now we have the same denominators, so it's easy to add it by doing cosine square theta plus sine square theta, which is equals to 1 using the identity. So 1 over sine theta over cosine square theta, and this is square theta, and this is the right hand side. And now for the homework, it will be exercise 16c, number 13c, page 277, and exercise 16c, number 13d, page 277, and